On September 11th, 2001, three of the world's most recognizable skyscrapers just crumbled to the ground in New York City. Now, beyond the profound tragedy, it also presented this absolutely shocking engineering puzzle. So today, we're going to dig into the official investigation by the National Institute of Standards and Technology, or NIST, to really understand the science of what happened.
Okay, so let's just start with the central mystery, the big question mark hanging over everything. Before 9/11, it was pretty much an accepted fact in the engineering world that fire, by itself, could not bring down a modern steel skyscraper. And that is why the complete pancake-style collapse of the towers was so staggering. It demanded a massive scientific investigation to figure out how the impossible actually happened.
You see, the question wasn't just what happened, but how. How could this possibly happen? To find the answers, the U.S. government kicked off one of the most complex, most detailed building failure investigations in history. It took years to meticulously piece together the exact sequence of events. And this quote from a world-famous architect really gets to the heart of it. The attack subjected the towers to forces that were just so far beyond anything they, or frankly any building at the time, was ever designed to handle. So the investigation wasn't about pointing fingers at the design, it was about understanding the pure physics of a failure that went way outside the rulebook of engineering. Right, so to get how the towers failed, we've got to first understand how they were built. I mean, when they opened back in 1973, these things were revolutionary. They were engineered to be incredibly strong, but also super efficient, all to maximize that open, column-free office space.
Okay, so let's break this down. The design was called a framed tube. Just imagine a really strong hollow steel tube made of all these columns packed tightly together on the outside. That outer frame handled most of the wind load. Then on the inside, you had a central core with 47 massive steel columns for gravity support, and that's also where the elevators were. Now, connecting that core to the outer perimeter were these lightweight floor trusses. That's what gave them those huge open floors with no columns. And tying it all together at the very top was something called a hat truss, which basically made the whole building act like one giant unified structure.
And this, right here, shows you the massive gap between what the engineers planned for and what actually happened. They did think about a plane crash back in the 60s, but the scenario was a slow-moving Boeing 707 lost in the fog. But what happened on 9/11? It was a whole different beast. A much bigger, much faster Boeing 767, packed with thousands of gallons of jet fuel used as a weapon. The sheer speed and, most importantly, the massive fire that resulted were just way, way beyond anything ever imagined.
So the impacts from the planes were obviously devastating, but they were really just the beginning of the end. What the NIST investigation found was that the impacts were the catalyst. They're what set the stage for the true agent of collapse, the out-of-control fires that burned across multiple floors.
Let's just walk through the timeline for a minute. At 8:46 a.m., the North Tower gets hit. Just 17 minutes later, the South Tower. But here's the thing that might surprise you. The South Tower, the second one hit, actually falls first, after burning for only 56 minutes. The North Tower lasts way longer, 102 minutes before it collapses. And then, way later that afternoon, 7 World Trade Center comes down after burning for almost 7 hours, and it was never even hit by a plane.
Okay, this is the single most critical point in the whole thing. The explosions from the planes hitting the towers blasted away huge amounts of the spray-on-fire insulation that was protecting the steel columns and the floor trusses. The structural damage from the impact was bad, sure, but the towers were so redundant they could actually handle it. But what they couldn't handle, what no building could, was having that now unprotected steel skeleton just cooked by the jet fuel fires.
And this brings us right to the core findings of that massive NIST investigation. The final conclusion was that fire, acting on the already damaged structures, was the primary cause of all 3 collapses. So let's break down exactly how that chain reaction worked. First things first, we have to clear up a really common misconception. The fires did not have to melt the steel. Steel melts at around 1500 degrees Celsius, and the fires weren't that hot. But they didn't need to be. At just 600 degrees Celsius, a temperature easily reached in a big office fire, steel loses about half of its strength. It starts to get soft, it sags, it deforms under all that weight. But it wasn't just about the steel getting weaker. The real killer was something called thermal expansion. You know, when you heat up metal, it expands. Well, as those long floor trusses got superheated by the fires, they started to expand and sag downwards. It's kind of like if you imagine a tightrope getting longer and suddenly drooping in the middle. And that process is what led to what's known as a progressive collapse. It's basically a domino effect, right?
A failure in one small part of the building transfers an overwhelming amount of stress to the next part, which then fails, and then the next, until the whole system just catastrophically fails.
So let's trace that chain reaction for the Twin Towers. Step 1. The impact blasts off the fireproofing. Step 2. The fires heat up the now exposed steel trusses, and they start to expand and sag. Step 3, and this is the absolute key, as those floors sag, they start pulling the strong outer columns inward. Step 4. Those columns, already getting weaker from the heat and now being yanked inward, finally buckle. And once that happened, well, there's nothing left to support the massive weight of all the floors above the fire. The entire top section of the building began to fall, pancaking all the floors below it.
So what this table shows us is how that one core idea, uncontrolled fire, caused all three collapses, but in slightly different ways. For both Twin Towers, the trigger was the same, sagging floors pulling the columns inward. But for WTC-7, which was only hit by debris, the mechanism was a little different. In that case, the heat from the fires caused a critical floor girder to expand so much that it was pushed off its seat, triggering the collapse. But in all three cases, the ultimate cause was exactly the same: fire causing the failure of steel structures.
You know, the NIST investigation was never just about figuring out what went wrong in the past. It was about protecting the future. The findings led to the biggest overhaul of building and fire safety codes in modern history, all to make sure that the lessons learned from this tragedy would make future buildings safer for everyone.
The final report was absolutely massive, and it ended with 31 specific recommendations to improve the safety of tall buildings. And we're not talking about small tweaks here. These were huge, fundamental changes designed to prevent a fire-induced collapse from ever happening again.
The reforms that came out of this were just so comprehensive. They covered every weak link in the chain. They required stronger fireproofing, the kind that can actually stick to the steel better and not get blasted off. They mandated backup water supplies for sprinklers, so one bit of damage can't take out the whole system. New skyscrapers now need an extra hardened stairway for people to get out, and even special protected elevators for emergencies. It was a complete, top-to-bottom reimagining of what safety looks like in a tall building.
At the end of the day, the collapse of the World Trade Center forced the entire world to ask a really tough question. It completely shifted engineering, from just designing for things you expect to happen, to actually considering and planning for the effects of the unthinkable. And that's a challenge that continues to shape how we build our world today. A lasting legacy of resilience that was born from an incredible tragedy.